Oh, actually, it does store everything on the computer, but everything is like it's on a computer. No, on the phone computer, there are file system, and I don't think I can access it from it's like a partition. Yeah.
Yeah. So those are environment variables, and what you will mostly be dealing with is the ROS master URI, basically setting up different masters to interact with like different systems, the robot or the rally car. Depending on that, you set the master to be a different system. That's it. So the next thing is, for example, here I have my ROS workspace, which is called MFET 442 ROS1. As you see, it has something built in. So now if I source my workspace, so whenever you have a workspace and you want to refer to packages in your workspace, and your ROS system, if it throws error saying, I don't know where this package is. So what is missing is you're not sourced your workspace. So for that, you just do source devel setup.bash, and that will basically source the packages in your workspace. So what really happens? Again, we do the same thing, and again, we find out ROS variables. So if you see here, particularly in package path, now in addition to your OPT ROS, the original libraries which came with ROS, it also added your packages in your workspace. So now basically ROS says, okay, there are also packages in this particular workspace, and you can also go and like try to detect them here.
Wait, so did you go into the workspace you're going to be working from and then add the packages? Is that what you do?
So to basically do that, what you do is you go into your workspace. So in my case, it's called MFET 442 ROS1.
Okay. Yeah.
And then you source devel setup.bash.
Do you have to do that every time, or once you source it, it's
so every time you open a new terminal, you have to do that.
Okay.
Yeah. So if you have a fixed workspace, you're always going to be working in, and you know you're going to be using ROS1, what you could do is basically add it into your bash terminal. So what it does is whenever it starts a new terminal, it will source it. So how to do it? Here you go. So you basically edit something called a bash RC file. And it's always in the home of your Linux environment. So in general, when you're referring to home in Linux, you can use the tilde symbol to refer to the home. So you do tilde and then .bash rc, and it will pop up this file. So at the end of the file, you can basically go and be like source. In my particular case, it's like workspace MFET 442 underscore ROS1 devel /setup.bash. So you provide the full absolute path, because in this particular case, it's sourcing from some reference point of the bash. So you provide reference from full absolute path to your setup.bash, and it will source not only ROS, but also your packages.
Okay.
Yeah.
Why do you have to put it into your workspace? Why can't you put it, I mean, why do you have to put it in a specific location of the workspace? Why can't you just put it on?
Yeah, so so if you see, sorry, let me, I can put it back.
Well, I need the command type.
Yeah, I'll put it back.
Oh, it's not about
Okay.
Can you do the same here? This flash receipt with a source OPT, everything?
Yes, you can do that as well. So I basically did this to go to the bash RC file, and you can edit the bash RC file from here. So why do you have to do that for setup.bash? Here you go. So if you see the devel folder of your workspace, you have this thing called setup.bash or local setup.bash. All of them are essentially doing the same thing. They're configuring the Linux terminal environment variables to actually detect your packages. That's all. So when you do ROS knows where to look up the packages. That's it.
Oh, I see.
Yeah, and for your workspace in particular, it creates a setup.bash file in your workspace.
And if you have multiple workspaces?
Yes. So basically what happens is, for example, there is something called underlay and overlay. So what it essentially means is overlay means something superior and underlay is like deriving from the overlay. So if you have an order of workspaces, so you create, let's say, workspace number 1, which has a bunch of your important packages, which you generally use. And your workspace number 2 is, say, for example, for one particular turtle robot, you're using it. And you want to also use packages from workspace number 1. What you do is basically source ROS first, then workspace number 1 you source, and then workspace number 2. So just do it in that order. Then whenever you run, it will detect all of these packages. That's it.
So when you source it in the order that you are sourcing it, the ROS would know that order is the order of priority, right?
Yes. But basically, if you have similar packages across 2 places, it will use the one with which you source last.
Okay.
So in this particular case, so if you see here, the first place it will look for any packages is this, my home package of this workspace. And then it look at ROS for if the package is not available in my workspace, it will look at it in the ROS repositories. So that is the order it follows for looking up packages. Yeah. So the next thing is, I guess all of you are comfortable with creating a workspace, creating a package in your workspace. Is that fine?
Yeah.
Yeah. So always when you create a workspace, you create a folder and you put a folder called SRC in your workspace, this particularly. And then all your packages will be in the SRC folder. And the way you create any package is pretty simple. All you're going to do is catkin create package, your package name, and bunch of dependencies. And the next thing is, do you guys have any questions about publisher and subscriber in ROS?
So we can have a publisher and a subscriber in the same node, right?
Yes.
Is it better to have it separate?
Not necessary. So it depends on the functionality of your code. So for example, let's say you're writing code to control an arm, but you want information from camera, but you're also want to send data to your arm controller node, and you're only doing the planning instead of actually writing to the motors. So what you do is you subscribe to the camera there, and you're getting data from the camera, you're doing some planning, and you're basically sending out the data to the motor controller through a publisher. So you can have a subscriber and publisher. So it essentially depends on the functionality you want to build into your code. So if your code requires data from multiple sources, you get data from multiple sources and through subscribers or services. And if you want to like send out data to some other thing in the same code, you do it through publishers. So you can have publishers, subscribers, everything in like one file. Yeah.
What's the file format of the node? It has to be a Python file.
So it can be either Python or C++. There are support for other languages, but the default compilation is supported for Python and C++. So if you're writing codes in C++, every time you edit the file, you have to rebuild it. So to do that, you basically like do catkin make, and it builds the package. But if you have Python script, you don't need to like rebuild it every time. So if you edit, you can run it. Because it basically references it to the original file and it just runs it like using a Python interpreter.
So you just save the file.
You just save it and you should be able to run it. You don't need to like rebuild the package. But for C++ files, you need to rebuild because C++ code is not interpreted. So it builds an output file and you're going to use that to run. Yeah. Any other questions regarding creating a publisher and a subscriber? That's great. So okay. So whenever you get some error like this, which is basically like you type in some ROS command and it says this command is not found. It essentially says you have not sourced ROS, or the Linux terminal doesn't understand like ROS command. So like I told you, the first thing you need to do is set up ROS. So I did the same thing. I have like a smaller alias setup. So whatever this is doing is essentially like source/opt ROS. No setup bash. So this won't work on your systems. It only works on mine. So if you want, you can also set it up yourself.
What was the process for setting? I remember you said. You're doing that, yeah.
So if you see this particular line, it basically says I'm setting up an alias, which is this word essentially means do this command. That's all. So you can just put this line in this. So what it does is it doesn't really source ROS, but it creates a shortcut for you to do sourcing of the ROS.
And that's better than actually sorting, because if you have ROS 1 and ROS 2.
Yes, so you can just source whichever you want, but you don't need to type as much. So yeah, you can also.
You have to delete, if you're using ROS 1, you have to delete ROS 2, and if you're using ROS 2, you have to delete.
You have to like resource them, and some environment variables you have to like remove, unset. Yeah. Yeah. So the other ROS code. So some command line tools to basically like look at your environment. So one of the things is ROS topic list. It basically lists the set of topics, but there is also ROS topic list with an option called V. It essentially means like verbose. What that does is again print the same thing, but it gives you more information. So in this particular case, as you see, it says, okay, this is the topic, and it says this is a published topic and not a subscribed topic. And it gives you the message type of the topic. And it says there are like one publisher who is publishing to this topic.
We don't have ROS code running, and ROS topic is not going to work.
No. So if you see, it says like unable to communicate with master. So ROS topic, what it is doing is basically communicating with master to see like which are all the registered nodes and what they're providing. So here is another thing. This says one publisher, basically because for any topic, you can have multiple publishers and multiple subscribers. So if I have like 2 cameras, both of them can write to like the same topic saying like, okay, image. Ideally, you wouldn't want that. You want to separate out camera data. But for example, if you have IMUs, let's say, which are kind of overlapping, you can do that. Or you have like 2 nodes doing some kind of planning. One is doing faster, one is doing slower. You want to like compute with both, you can do that. Basically things like that. So basically you can have multiple nodes publishing to the same topic, multiple nodes subscribing to the same topic. And then the next thing, so ROS topic, in addition to list, also provides 2 other options. One is called echo. What echo does is basically like print out some data in a particular topic. So let's try some example. Okay. So one other thing in Linux in general, once you have set up your environment variables, your tab auto completes most of the things. So whenever you're typing, after you type partially, you can just do a tab and it will do autocomplete. And it will also give you options. So for example, in this particular package, there are like a bunch of scripts I can run. So if I do tab, it will list like the set of packages, the scripts I can run.
I think in ROS 2, you have to install something.
ROS 2, there is like a particular package you have to install and it will do the same thing. It's basically like auto completion for ROS. So here is some simple turtle sim running. It launches a bunch of topics. So let's see like what are the topics. So in your lab 2, basically I gave you like a batch file that was essentially recorded from a turtle sim which was like controlled with teleoperation. So if you see, it prints out like pose of the turtle, which is essentially like where is the turtle in this simulator, some color, and it has like the default ROS out for the 2. And there is also a subscribe topic for command well, which is essentially providing the velocity which the turtle sim uses to set the velocity of the robot. So your echo basically like subscribes to the topic and prints out the data. So essentially your echo provides a way to subscribe. So if you do echo and the topic name, it will just subscribe to the topic and it creates like an infinite subscriber. So it keeps printing it every time there is a publishing. But say if you want to view it only once, so what you do is ROS topic echo, the topic name, followed by -n1. So -n says number of times, so you can be like, I want to like do it 2 times. So you can do -n2 and it does it 2. So and they are basically separated by this. If you see that, it means like that's the end of one message and then the new message is starting. Similarly, what we can do is also do a publishing through ROS topic command line. So you don't need to actually create a script to publish. You can also publish using the ROS topic tool. So the way to do it is again pretty simple. You do ROS topic pub, and then you do your topic name. So let's say in this particular case, we want to publish to TurtleSim command well. And you provide the type of the topic. So in this particular case, it's geometry messages twist. And then you provide the data in YAML format. So if you do tab, it auto completes for you. So you don't need to really like go and type in each of those. So in this particular case for TurtleSim, we know it's geometry messages twist. Even that it auto completes if you do a tab. So you don't need to like really go and type in each of them. And then you provide some particular value and your robot moves. So it told something here, which is basically publishing and latching a message. So what that means is when you are publishing a message in ROS with a publisher, there are different options for publishing. So in your lab assignment, you used a while loop, infinite while loop with some particular rate to publish, and it was publishing at that particular rate. So that essentially means in your topic, someone is like constantly writing messages to that topic. So the other option is something called a latched message. What that means is you publish only once, but your topic doesn't get rid of that message if someone reads it. So essentially, it's the topic has like a memory which is holding on to the last published message, and whenever someone reads it, it will be like, okay, this was the last message, you take it, and it still holds on to that until someone new publishes to this topic. So that's essentially what a latched message is. So in this particular case, if you do ROS topic pub and you don't specify any additional parameters, it publishes once and it holds that topic for future use. So if any new subscriber joins and says, I need data from this topic, it will provide this old message. If it is not latched, you don't wait for the old message. Any new subscriber is just waiting for the new or latest message, which is going to come. Yeah. So the ROS topic pub also provides you an option to set rate, which is like how the publisher you created through code. So to do that, you just do like -r and some particular like rate. So in this case, like say 10 Hertz. So what it does is it essentially like publishes this message at 10 Hertz for you.
Right now it's publishing.
Yeah. So this is basically like publishing at 10 Hertz. So if you see like the turtle keeps going and it collides. Okay. So that's essentially like how you interact with like ROS topics. So if you want to get information about like the message types in particular, there is also something called ROS message. So you can do like ROS message show or like list. And then it lists the set of all your messages. So if you want like of one particular thing, you can do like, let's say TurtleSim. So it says in TurtleSim, there are like only 2 types of messages available, color and pose. If you do like STD messages, there are like so many types of STD message types.
So in this case, for example, STD messages, each one, so STD messages is a type of message, right?
Yeah.
And the other one / is the type of value, right?
So this is the type of the message. Float 64 is the type of the message. STD messages is basically the package which has this message. That's all. So it's just the name of the package. Geometry messages is just a package which has a bunch of message types. Twist is the type of message. Exactly. So if you want, say, information, so this just is listing. So if you want information about each of these, so you can do the same thing, ROS message show. And let's say STD messages float 60. Float 32. So it says float 32 has one thing, which is just like data. So let's look at something which is like complicated. Let's say twist. So we have geometry messages twist. So it says, okay, geometry messages has Yeah, it has like a nested structure. It has like a linear, angular, which are again of vector 3, and they have like a float XYZ, XYZ. Similarly, for example, if you look at like pose, it has position, orientation, and each of them have like 3 or 4 values. Similar.
That list command only show the active nodes message type or
No, so ROS message basically shows you any message in the ROS environment. So it looks at, so for example, right now I'm not using something like a camera IMU value. So you can do like ROS message show sensor messages, IMU, and it just like describes the format of that message. So it need not be a topic which is available.
We can create our own messages.
You can create your own messages. So in your lab 2, I gave you your own service which was created. It's called FK. So you can create your own messages and services. Similarly, for equivalent to ROS message, there is something called ROS service. Not service, ROS SRV. And it's essentially the same as your messages, but it lists the service types. That's all. So for example, if you look at like ROS service show, let's look at HTTP services empty. So it's actually like an empty service. So you send an empty thing and you will receive an empty thing. That's it. So you don't really like and it shows like this is the format for like an empty service. So there are like different types of services you can use. So ROS service and ROS message are equivalent. SRV is for like service types, MSG is for message types. Any questions on these? Okay, that's good. And similar to ROS topic, you have something called ROS service, which essentially provides interaction with services. So if you do like ROS service list, it lists the list of current services which are possible. So if you see the turtle sim started like a bunch of services, one called kill, one called clear, one called reset, whatever. And you can do.
So what is the difference between the server and the service?
What is the difference between the server and the service? So in this particular case, this is just the names of the service. The one who is providing this service is some node which is hosting the server. So right now, if you do -n, it tells which node is actually hosting the server. So clear is a service provided by a turtle sim node which has the server. So there is no client. So if you can create a client to actually like call that to do something. So there is no client which is created, but it is just listing like the servers who are providing the services. So in this case, we have this thing called clear, which is a service provided by turtle sim. What it does is essentially like clear the screen. So if you want, we can basically like call it using terminals without creating a client. So in your lab assignment 2, your last question was essentially creating a server. And for example, if you wanted to test the server, you can write a client to call it. The other option is you can also test it by using command line tools to essentially create a client. So one way to do it is essentially ROS service call, and you provide the name of the service. So in this case, clear. And that after that, you provide like similar to the ROS topic echo or ROS topic pub, you're like going to provide the message here. So in this service message, it's basically empty. So that's what you need to send. So you just like send an empty thing and it gets cleared. That's all.
When we call the services, we don't need to say the server name in the command, right?
No, so you basically only specify the name of the service. You don't need to specify the name of the server. Yeah.
So and the backslash is because we are calling the service, not the server, right? So why the backslash is the.
So that is the name of the service /clear. Yeah. So it's /clear itself is the name of the service. Yeah. So ROS uses like namespacing. So for essentially like you can do like turtle1 set pen, turtle2 set pen. So it's essentially a way to like provide namespaces. That's why they use slashes. But that's in the name of the service. That's all.
Service and server put in the same, like for example, Python file or separate files.
So server hosts the service. So service is basically the name you provide when you create the server. So server is hosting the service.
Okay.
Yeah. So basically what happens is you create so you provide, I forgot the exact name. So you provide like name and then the service type and some my function. So this is how you create a service. So this file will essentially be called the server, and the clear you are seeing is just this name of the server. That's all. And the name for this entire file, you would have done something in the beginning called rospy.init node, and you would have provided some name. So that will be the name of the node which is hosting the server. And this is just the name of the service. So what it does is whenever you call the service, it calls this particular function you wrote. That's all in this node.
So here, this name is the service name.
Yes, this name is the name of the
Where
service.
can we name the server?
This is the name of the service. The server has no name. The server is essentially hosted in the node. So the node name will be the server name.
How do you create that server? Because it has an extension .srv. So how do you create that?
Oh, so .srv is not a server. .srv is it's similar to your message type. So it's a service type. So it's the data format, like int float. So for example, to call this, you need to provide some particular thing. That is the message format. So .srv file essentially hosts two things. One is what should be the request data type and what should be the response data type. So for example, if you let's go to your
Just
terminal.
open a notebook, that and write it and save it as SRV.
Yeah, that's all. So if you look at your so the lab2 messages, I provided you something called FK SRV. So all you do is you create this file, which is called FK SRV. It has two things. One is the request, other is the response.
Oh,
So the first part is just the request, which has two things called theta and L. And the response again has two things called X and Y. That's it.
And it's always the same format, so we have to put these 3 dots and 3 lines, or it doesn't matter.
Yes, you have to. So this 3 lines is essentially separating the request type and the response type. So this is essentially a message type, if you think about it. Like any STD messages float, you would see like one float data. So this is essentially like a message type for the request. And this part is the message type for the response. So what ROS does is instead of you creating 2 separate messages, trying to integrate them, you just create one thing and name it whatever, FK-SRV. And in your assignment, I told you to import FK response and FK request. So ROS basically separates these two and creates new messages for you, which you can use. That's all. So when you call the service, for example, in this case, you'd be sending only the request part of it. And when you're responding, you'd be sending out only the response part of it.
When you meant like sourcing like the dependencies, remember that we have to change the CMake file and the package XML. So there is one part where we have the services, and we have to add there the FK server or not.
No, I'll come to that. How to add dependencies. Yeah. So yeah, those are about like services, service calls, topic calls. So any questions about like command line tools to subscribe, publish, service calls, and okay, that's great. Now let's just look at what he was asking, which is on essentially like how do you add dependencies. So in this case, I'm just going to my folder and let's look at like, let's say ROS1 tutorials package. So if I want to basically add any dependencies, I go to my package XML. So this basically is like my package XML. And all you do is, there are like three things. One is build dependencies, one is build export dependencies, and something called execution dependencies. All you have to do is replicate something similar. So if you know your package is needed for build time as well as execution time, you can just like copy paste the same thing and add lab to messages in this particular case for your lab, something like that. And you do the same thing for execution, you do the same thing for export. And then it says, okay, whenever I'm running this package, I want these dependencies. That's how you do that's how you change the package XML. So there is other thing you also have to change called the CMake list of your package. So it's not of the workspace of anything else. It's only of your package. So in your package, you'll have two things. One is package XML and other CMake list. So if you go to CMake list again, all you have to do is in find package, you want to add the dependency package you want to find. So in this particular case, it would be like lab2 messages, something like that. Whatever the name of the package you want to add the dependency to. That's what you need to do. So all this add service files, add message files, all this is essentially, if you read above it, it says to generate a service. So I provided you a folder called lab2 messages. That is a package which has a new service type. So that package has to generate a service. So for that, you would have to like go and edit this. But for your package, if you're only like adding a dependency, you're not going to edit any of these lines. You're only going to add it in your find package, because that's all you want. You want to just find the package and find anything in the package. So you just add your dependency here. But if you are creating your own messages or your own services, then you would have to like uncomment these and add them here, what you are creating.
For that working, because you send it as a folder, so we have to also do the hacking to that folder.
You don't need to do anything to that folder. You just have to add it in your workspace source folder and you use it.
There is because what I did, I go to the CMake file and go to the package XML and I
Off.
of mine.
Okay.
And I added the lines that were missing from the other file.
Yeah, so you don't need to. So what in the other file, I've basically edited it to build a service type which I've created. But you're not creating a new service type in your folder. You're just importing it from somewhere. So you don't need the same lines. So if you add the same lines, it will essentially throw error saying like FKSRV is not existent.
What I did, added the same dependencies, not that message. I have the dependency that.
But where did you put the FKSRV?
I created a source folder.
Yeah. So if you create your own SRV folder and you're building it, yeah. So if you're creating your own SRV folder in your package and you're adding it, then you're creating your own new service type. That's essentially what it is doing. It is not importing from lab2 messages. It's building your own thing for you. Yeah. Basically, like what the lab asks you to do is import a dependency. So you don't need to do much. You just have to add one dependency in your CMake list, just here, which is whatever, my dependency. That's it. That's all you need to do. So if you want to create your own service message, then you can copy how the other package is provided to you. Yeah. Okay. Any questions about adding dependencies or anything? Okay. Some important tools for today's lab. One of the thing is basically something called rviz. So rviz is basically a ROS visualization tool. You can run it using just rviz, or you can also run it using ROS run, rviz. It does the same thing. It calls the same file. Everything is the same. Yeah.
What's the difference between rviz and the debug?
I'll explain. So rviz is basically only a visualization tool. It's not a simulation tool. So you can visualize ROS messages, ROS topics. That's it. Gazebo basically provides you a simulation tool. What that means is you can actually simulate physics. You can simulate collisions. You can make a motor move in that. You can create a motor in the gazebo. You can create your world and you can have objects interact with each other. And gazebo basically solves the physics for you on how they're interacting, how they're moving. It provides the ability to put gravity or zero gravity, move them in space, things like that. So it's essentially kind of simulating your real world physics through some simulation back engines called Bullet and few other options.
Right, so in the gazebo, like, for example, you have a table and you remove the table, then the object that put on top of the table will drop to the ground.
If you have set gravity,
Okay,
and if you have not set those objects as static. So it is basically a simulation tool to simulate physics, but the physics, you can set it to be whatever you want. So if you set gravity, if you remove the table, it falls. If you don't set gravity, they're just like floating around. So if you set the object to be static, it means it's fixed, so it never moves. So you can set different properties and you can simulate all of this in Gazebo. And Gazebo basically provides you this option to do all of this, and it solves the physics for you. So you don't need to like do anything for that. And in addition, it also is a visualization tool. So it provides you an UI to interact with it. But mainly the backend of the Gazebo is what is the core component of Gazebo, which is simulating physics. RViz, on the other hand, is a purely visualization tool. So there is no like simulation going on. So if anything you see interacting in RViz is essentially because you have some code you are running, which is actually showing the interaction. So if you see images of RViz where like robot is going and colliding, it essentially means like there is some backend program you're running, which is doing this computation or like doing anything. So RViz is just giving you a window to see that, that's all. So how do you use RViz? RViz is pretty simple. There are like few main things you need to do. One is your left window, which shows you the list of things you have added into RViz right now. So basically, in this particular case, I don't have anything added. So it just says, okay, there is some global reference frame. There is some grid, which shows like grid or not. So you can choose that option. That's it. There is nothing really, there's nothing else which is being published right now. So if you want to add your own topic, which you want to visualize, what you do is something pretty simple. You go to add and you do like by topic, and you can choose any topic which is being published. So by topic essentially lists the list of topics which are currently available. So if you go to your terminal, if you do ROS topic list, there are like a bunch of topics, and RViz basically says which of them you can actually visualize. That's it. So you can add like any of these topics you want, and it will be like, okay, you can visualize them. And it shows you like, okay, what is the topic type? Is someone publishing to it? What is the queue size, and what will be the shape of the visualization, things like that. That's it. You can add many things. You can add things like images, for example. You can add like maps, you can add paths, you can add like so many things. So for example, let me try adding like a map.
can I have map?
Yeah. So for example, if
You have to save the map in the source file.
no, your map can be anywhere. It has to be somewhere in your system. That's all.
You mean your main works?
In not necessary in your workspace. So when you run the map, you're going to provide the reference to where the map is. So that will be where it is essentially. Let me download it.
You know what format the map needs to be in?
Yes, I will show you. We will get to maps later on, but essentially the map format is like two things. One is something called a PGM file, which essentially is, oh, I have it somewhere here. PGM. Downloads. Okay. So if you see this is like an image format, which is showing you the map. In addition to that, there is like a YAML file, which is providing description of resolution of the map and where is the origin.
You
Something
need both of those.
you need both of those to run a map.
One is like the scale, and then the other is the image.
Yes, the image basically provides where the objects are, where is a wall, where is like an open space, all of that.
Oh, okay.
Using like colors, it represents it. So when the map loads it, it can interpret those.
And then so you save them together or in one folder or file directory?
You save them together in one folder.
Okay.
So they should both be in the same folder. That's all.
And the same name?
They'll be the same name. So technically they can have different names. So what happens is in your YAML file, there is the name of the PGM. So
Yeah.
that should match. That's all. So if you see, there is a new topic called map, and we can add it. We can visualize the map, and it will show you the map. And you can also like click different points on the map, and it will tell you like. So these points can get like published into your space. So essentially, if you look at the ROS. So there are like 2 points. One is click point, one is initial pose. So rviz basically provides you an option to publish to these 2 topics. So the 2D nav goal essentially published to the click point, and the pose estimate publishes to this topic called initial pose. That's what happens. So for example, when you are setting up your robot rally car, you can basically like, if you want to look at like points on the map with respect to the origin, say for example, to create your own path, by clicking a set of points, you can create your own path. So how do you actually get these points? So you can use this 2D nav goal or 2D pose estimate to essentially like click a bunch of points. rviz will publish to that particular topic, and you can read from the topic.
Sorry, could you repeat that? What are you trying to do with the 2D nav goal point?
2D nav goal essentially gives you an option to get publish a point from rviz. That's all.
And so then if you had a computer, if you had a rover, right, running, and it would take that and it would subscribe to that rviz, it would take that and would drive to there.
If you set it up to actually take the goal from there.
Yeah.
So basically what you need to do is you should say the goal for that would be like the click point or the move base simple goal. Both of them basically are the same thing. So if you set up like move base, which is a package which does path planning for you to actually take the goal from this particular topic, then whenever you click, it will choose that as the goal and move to that. So if that is how it's set up, yes. Yeah, and basically that's rviz for you, which is it has a bunch of things to like visualize. If you want to measure, for example, your map estimates or distance, you can use like the measure tool, and it'll tell you like how much is the distance.
Can you use rviz to make a map?
You cannot use rviz to make a map. rviz is just a visualization tool. So when you're making a map, if you want to see how the map looks, whatever you've built till now, you can look at it through rviz. But rviz will not like make a map for you. So you can use, there are like packages available called Hector Slam or Hector Mapping or Google Cartographer. So these are all like essentially Slam packages which allow you to do a map, create a map. But they don't give you an option to visualize them. So rviz basically like provides you an option to visualize them when you're building the map. Okay. So today's one of the problems will be like using rviz, which is basically I've given you a package, run it, and you have to load an image. It's like an image topic which is being published. All you have to do is go to add, go to by topic, you'll see the image topic, just add the image, display it in rviz, take a screenshot. That is your 5 points. Okay. Any questions about rviz and visualization?
So you can also add like a point cloud here.
Yes. So you can add like basically variety of topics. So for example, if you see here, you can add like camera depth cloud, which is essentially some version of point cloud. You can add like laser scan, which is essentially what your LiDAR generates. You can add like map. You can also add your own markers. For example, in your file, if you want to publish a set of points, which is indicating your path when you're running the race. So you can use the markers to create your own path and publish.
If I have a role in the LiDAR sensor, I can go to make it like work and I can see the.
You can see the LiDAR points in RViz in real time. Yes. Yeah, and you see like different point cloud versions, like point cloud 2, the pose of your robot, like 2D or 3D poses. You can also visualize something which we will be dealing with, which is axis or coordinate axis. So we talked about like transformations, Baxter robot having like multiple transforms. So you can actually look at what is the relationship between like each of them using like axis. So you can also add axis which are already existing in the ROS system. Yeah. So any other questions about RViz? Yeah, that's good. So basically that's what we have for RViz. So then there is another tool. Let's kill the map. So then there is another tool called RQT plot. So you can run it using RQT plot, or you can do like ROS run RQT plot. RQT plot. So RQT is a series of tools. RQT plot is just one of them. So what it provides you is basically a time-based visualization. So RViz is giving you a visualization of the current instant or the current frame. But if you want to, let's say, look at like how the velocity is changing over time, or what is the shape of your like velocity curve, things like that, then you can use RQT plot, and it provides you a time-based visualization. So the way to do it is you just go and in your topic, you provide like what is the topic you're going to visualize. So in this case, there is like turtle sim, which is providing pose. So let's visualize the pose, and you just like add it, and it just prints it for you over time. And you can basically change the axis dimensions here using this particular small plot symbol. You can specify like left limits, right limits, all of that, similar to any plotting tool. And it just provides you. And if you want to choose one particular element of your entire message, you can also go to this option. It'll tell you what you want to choose. So if you want to just plot only the X component, so you can choose X, and it plots only the X component, things like that. And sorry, if you want to like delete one particular component, it will delete those components. And right now there's nothing, and you can add if you want, remove whichever you don't want, things like that. So that is basically RQT plot, a simple plotting tool, very minimal. And I think your second question is basically using this, second or third, I think, is essentially same thing. You have a package, you run it, and you visualize the path, essentially the X path in RQT plot, and give me a screenshot of the RQT plot image. That's it. So RQT plot, again, you can use it to debug if you think some velocities are not evolving properly or position is not changing properly. You can use them to debug. Yeah, that's RQT2. Then there is something called RQT console. So ROS run, let me go back. So RQT console is basically an important tool whenever you're doing any debugging. So what it provides is basically a terminal, a visualizing console, which lists any set of errors or warnings, debug information, anything, even like print information, which any of your nodes is publishing. So for example, in this particular case, let's look at like the turtle sim node, and let's just move the turtle a little. So if you see, the turtle sim actually printed a bunch of warnings through ROS, and they're also like captured in the console. So it will be like, okay, there was a warning which occurred, and this was the warning message. And this, which node is the one which is printing this warning? What is the severity of this message? It's a warning or an error or whatever? And it will tell which topic resulted in the warning and what was the timestamp when this warning occurred. That's it. The location is essentially providing you the location to the log file. So all this is also logged, and you can look up the log file later on if you want to, but this says the location of the log file. But these are like the warnings which get printed. So this is an important debugging tool. So whenever you are using different packages, most packages build in like warnings and errors on how you are using it. So if there is something going wrong, it will throw like a warning on you're not using it properly, whatever. Similarly, like if there are errors which occur saying like, okay, computation failed. For example, in Baxter's case, when you use inverse kinematics, Baxter, sometimes the computation fails. And it will be like, I cannot find a solution. That gets thrown into like an error. And you basically like go to RQT console and look at it. Instead of looking through a bunch of messages, you can be like, okay, remove debug, remove info, remove warnings, remove fatal. Only I want to look at errors. So here you can just click which one you want. So in this case, if I want only warnings, I disable everything else and I only have warning, and it shows only the warning messages. Similar like that. So RQT console essentially is like a debugging tool to look at like any console messages. Any questions about RQT console? Oh, could you repeat that?
How did you pull that up?
The RQT console? Yeah. So basically you do ROS run, RQT console, RQT console. All RQT tools, simple, ROS run, RQT, whatever the tool, then whatever the name of the tool. Many of them also have like a command line thing, so you can also directly do like RQT console and it will bring it up as well. Then one more thing is something called RQT graph. So what this does is basically provides you the ROS graph, which shows like what are the set of nodes, what are the topics available, and what is the communication between the nodes. So we discussed the ROS graph in the class. So the way to bring it up is using RQT graph. Yeah. So that will be all for ROS 1. So you can do your assignment, and maybe next week we'll do like a similar version for ROS 2. And because the current lab is only based on ROS 1, so you should be able to like finish the lab using whatever was explained. Any questions? Yeah.
Oh, no question. Any help with
Oh, okay. Sure. Let me